We present the tool-based advisor MigCast, featured in our NoSQL management middleware Darwin. Flexible schemas usually evolve frequently, and the resulting legacy data has to be migrated according to the current schema in order to get a structurally homogeneous database instance. When developing NoSQL-backed applications, it is crucial to keep two metrics in mind. Short access times are relevant for application performance and thus user experience. On the other hand, migration costs can significantly burden the budget. These metrics constitute the typical trade-off between data access latency, i.e. the time it takes for data to be retrieved, and data migration costs, i.e. the charges occasioned by migrating the data. Here MigCast comes in handy, a tool-based advisor in Darwin for exploring different data migration strategies and potential consequences when evolving the data model along with the legacy data. We can explore alternative parameters that describe the migration scenario of question, upon which financial costs and latencies are predicted. To this end, MigCast maintains an internal cost model, taking into account characteristics of the database instance, data access patterns, expected workload, the kind and frequency of data model changes, and cloud provider pricing models. Let us run the simulation with the default settings, to which we will get back in a minute, in order to actually see the charts. For example, with the lazy strategy, the red graphs, latency is generally high, but migration costs are zero. With the eager strategy, the light blue graphs, latency is generally low, but migration costs are maximal. Here we see the trade-off between data access latency and data migration costs that we were talking about earlier. We can achieve a compromise regarding this trade-off with the incremental strategy, here the dark blue graphs. With the incremental strategy, all legacy entities are migrated according to the new schema after a certain number of releases, and a lazy approach is applied for the interim releases. Thus, for releases 5, 10, and 15, you see that the migration debt is zero. Migration debt refers to the charges that would have to be invested in order to migrate all legacy entities to a structurally homogeneous database. Since at these increments of 5 all entities have been migrated, all debts are paid off, so to speak. In this chart, you can also see that the migration debt is always highest with the lazy strategy and zero with the eager strategy. MigCast has a lot of different parameters that can be set. We cannot get into the details in this video, but let us motivate the other migration strategies that we have proposed. We ran our MigCast simulation with an initial number of entities of 20 million, a growth rate of 10%, and with a data access pattern of an 80-20 Pareto distribution, meaning we expect that in 80% of the cases, 20% of the data entities are accessed. This is a typical phenomenon that we call hot data. As the name indicates, hot data is accessed more often than cold data. Now, another significant insight you can draw from the charts is that in order to get good latency times, it makes sense to keep hot data up to date, that is migrated to the current schema. The advantage of keeping hot data up to date is utilized with the proposed proactive strategies. Proactive strategies use an access cache and migrate that data which has been recently accessed, based on the assumption that these entities will likely be accessed again in the future. We have implemented a predictive migration strategy that uses exponential smoothing with a weighting factor that determines the actuality for each entity and thereby the likelihood to be accessed again. Last but not least, a hybrid approach is the adaptive migration strategy, where the predicted set of entities to be migrated is augmented by entities that are affected by multiple complex evolution operations in order to minimize possible cascading migration effects and exceptionally large latencies. All proactive strategies propose good compromises regarding the trade-off between data access latency and data migration costs, and their graphs can usually be found somewhere between the eager and the lazy graphs. Thanks for watching. We hope you enjoyed this video. go visit us online and try out Darwin yourself.